Welcome to math class. Today's topic, multiplying and dividing terms with exponents. Part 1, Invasion of the Exponents. Today's learning goals are, I can multiply like terms with exponents. I can divide like terms with exponents. I can understand that a term to the 0 power is equal to 1. So before we begin diving into our learning goals, I want to take a quick look at what is an exponent, just to make sure we're consistent and everybody's on the same page with vocabulary. So here's what an exponent is. Okay, an exponent is the small number to the upper right of a term. So if we have something like 3 to the 4th power, that 4 is the exponent. And if we have something like x to the 3rd power, that 3 represents the exponent. Okay? And what does an exponent do? That exponent represents repeated multiplication. So here we have 3 to the 4th power, which is 3 to the 4th power is equal to 3 times 3 times 3 times 3, which is equal to, many people might say 12 because they would just multiply 3 and 4 together, but it does not represent 12. It is 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. Okay, and here we have x to the 3rd power, and that again is x times x times x. So that tells us what an exponent is. So let's take a look at our first learning goal. I can multiply like terms with exponents. So here I have two like terms, x and x. And I have both of them with exponents, x to the 3rd times x to the 4th. Now, a common error might be to say, well, that's x to the 12th because we're multiplying. Okay, well, let's find out if that is true. So we have x to the 3rd, which is x times x times x. So there's my x to the 3rd times x to the 4th times x times x times x times x. Okay, and what we see is we have a total of 7 x's that we are multiplying together. So our answer is not x to the 12th. Our answer is x to the 7th. Okay, well, how did we get that 7? And we got the 7 by taking the 3 x's, okay, because we had 3 x's that we were multiplying in the first term, and we had 4 x's that we multiplied the second time, and so we just take our 3 x's that we had here times the 4 x's and gives us a total of 7 x's. So we can look at that like this, and we can apply a rule that says x to the 3rd times x to the 4th is equal to x to the 3 plus 4, which is equal to x to the 7th. So our rule becomes when we have a variable and it is to a power times a like term and it is to a different power, then we take our term and we multiply it, okay, by one, each term by the other, and we take the exponents and we just add them together. So there's our rule, we add, okay, and we can do that with numbers too, just to kind of show us, because I think numbers are a little more concrete for us sometimes. So if we had something like 2 to the 3rd power times 2 to the 2nd power, our answer would be, hopefully everybody is saying or thinking, 2 to the 3 plus 2, or 2 to the 5th power. Okay, so 2 to the 3rd times 2 to the 2nd, and that is equal to 2 to the 5th power. So 2 to the 3rd, 2 times 2 is 4, times 2 is 8, so this actually represents 8. 8 times 2 to the 2nd power, which is 4, and 8 times 4 is 32. So if we do this, we should come up with the same answer. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we did come up with the same answer both times. Okay, so we're pretty confident that our rule is going to work in every situation, at least for like variables. And we'll tackle when we have combined terms at a later time. And let's take a look at our second learning goal, which is dividing like terms with exponents. So up here we have y to the 5th divided by y to the 3rd. And we can also write that as y to the 5th over y to the 3rd, because division and a fraction problem is a division problem. And so we can also represent that as y to the 5th, so y times y times y times y over y times y times y. Okay, y to the 5th, y to the 3rd. And so we can now start dividing. Well, y divided by y, that just gives me 1. And y divided by y is 1. And y divided by y is 1. So what I have left up here is 1 times 1 times 1, which is 1, times y, which is equal to y squared, 2 y's. And here I have 1 times 1 times 1, and that is just 1. And so we can simplify that by just saying it is y squared. And this works with numbers as well. Okay, so let's go with 3 to the 3rd power divided by 3 to the 2nd power. What's that going to be equal to? Okay, so 3 times 3 times 3, there's our 3 cubed, over 3 times 3, there's our 3 squared that we are dividing by. And now we can start canceling. 3 over 3 is 1. 3 divided by 3, 1. So on top, I just get 1 times 1 is 1, times 3 is 3. On the bottom is 1 times 1, and that is just equal to 3. So now I can look at my rule, and I see that at least in these two instances it works, so I feel like I'm developing a pattern or a rule, and that is that any term to a power divided by a power, we just take those two powers, those two exponents, and we subtract them from one another. Okay, and that is our rule for dividing exponents with like terms. And let's take a look at our third learning goal. I can understand that a term to the 0 power is equal to 1. So let's take an example of m to the 4th power divided by m to the 4th power. And we know from our pattern before that is equal to m to the 4 minus 4. So that is m to the 0 power. And we are saying that is equal to 1, when intuitively we might think, you know what, that should be equal to 0. Why is that equal to 1? How is 0 m's equal to 1? Well, let's take a look at our example here. Okay, and what we have is m to the 4th. So we have m to the 4th over m to the 4th. And what happens as we divide this out, we can cancel out m over, that's 1 over 1, 1 over 1, 1 over 1, 1 over 1, and so we get 1 times itself 4 times. Okay, 1 times 1 times 1 times 1, that's 1 still. And 1 times 1 times 1 times 1 is 1. So m to the 0 power is actually equal to 1. And that takes care of our 3 learning goals for today.